Hello learners, welcome to Hope Channel Kenya. This is your favorite program, Knowledge Quest. Here is Mr. Aguk Sam, your teacher for mathematics. Welcome to this particular mathematics class. Thank you. So we have been doing statistics for the past 3 classes. We had done the basic introduction to statistics. We had defined several terms as used in statistics. We discussed the basic method for data presentation, data collection, and we started on data analysis. And after data analysis, we had discussed several aspects such as the mean. So we are still continuing with the mathematics lessons. We are still continuing with the mathematics lessons, and the topic we are still trying to dig deep into is this topic of statistics. So let's continue digging deep into it. We are on statistical measures. We are on statistical measures. We are on statistical measures, and we have so far talked about the first measure, which is the mean. So far we have talked about mean, and when we were discussing about mean we simply said is the average. So several formula, we introduced 2 major formula for calculating the mean. The first one being the mean for ungrouped data, and also the mean for a grouped data, So those who remember, the mean for ungrouped data was said to be sum of x divided by n. Let me just write it the way we've been writing it. So we say that mean is x bar, which is the sum of x we divide by n. Remember, x were the observations, while n was the total number of observations. Then for our grouped data, we said that sum of fx all over sum of f. Sum of fx all over sum of f. That is the formula we also introduced. Remember, x for a group data refer to the midpoint. Then the next statistical measure that we also introduced was called deviation. The other statistical data that was introduced in the previous class was deviation. We said that deviation is how far a data is from the mean. How far a data is from the mean. And we said that the formula for calculating deviation, which is d, is equals to x, which is the observation in this case, we subtract the mean. The mean is what we refer to as the x bar. So deviation is how far a data is from the mean. We say that the answer can be positive or the answer can be negative, such that if the data is above the mean, it is positive. If it is below the mean, it is negative. And the third measure we also introduced in our previous class was what we are calling assumed mean. Yeah, we also introduced what is called assumed mean or working mean. Assumed mean or working mean. The one that we abbreviated with letter A. The one that we had abbreviated with letter A. Assumed mean, we said that we can get it or we can be given. So sometimes they provide you with the assumed mean, sometimes they don't provide you. So we say that if they don't provide you with the assumed mean, you can just pick randomly from the set of data given. But if it is a grouped data, the best practice is to pick the midpoint of the middle class. If there are two classes in the middle, you use the midpoint of the middle class with the highest frequency. So that is what was discussed. And also, using assumed mean, we say that we can get the actual mean. Yeah, we can get the actual mean if we are given the assumed mean. So if we have the assumed mean, we say the actual mean, which is x bar, can be obtained either for ungrouped data, can be obtained from ungrouped data, or can also be obtained from a grouped data. So we say that when we are talking about ungrouped data, the answer is very simple. We simply say that for ungrouped data, x bar is A plus sum of D divided by N. Remember, D, we have said, is deviation. Then for a grouped data, we say that x bar is A, which is our working mean, plus sum of FD all over sum of F. D in that case is the deviation. Good. So that is what has transpired. I'm just writing this formula because we are carrying some concepts as we continue with the next series of the statistical measures. So allow me to move to today's class. Illustrations was done in our previous classes, and those people who wants to have a recap of what was learned in the previous classes, you will just go to our YouTube channel, that is the Hope Channel Kenya, and you'll find the recordings of all these classes. So always follow up. You can subscribe to the channel. The moment a new video is posted, you are given, or you have an alert, and watch it instantly. So today I want us to advance the knowledge. In our previous class, I said that the knowledge of assumed mean can be used to find deviation. The knowledge of deviation can be used to find the mean absolute deviation. The knowledge of absolute deviation can also be used to calculate the variance as well as the standard deviation. So today I want us to introduce the concept of absolute deviation, as well as the concept of variance, and also the concept of what we call the standard deviation. So I hope everyone is now settled. We can begin. Everyone is settled. We can now begin. So I'm going to start with what we are calling the mean or the absolute deviation. So I want us to talk about what we call the absolute. You know, simply, anytime we are talking about the word absolute, absolute means we are going to ignore the negative signs. We only pick on the positive. So for absolutes, we are only picking the positive, not the negative. So absolute deviation is simply the positive deviation. So what you do in such a case, just ignore the negatives. You will be having an absolute deviation. So that one is a very good introduction. So let's start with absolute deviation. So somebody can write absolute deviation. Absolute deviation. Absolute deviation. So absolute deviation is having a symbol D enclosed by two vertical lines. So if I just write D, that is just deviation. But if I put two vertical lines in between, that now stands for absolute deviation. And I said absolute deviation only takes absolute deviation only take positive values. Only take positive values. Only take positive values. Only take positive values. What does this one mean? This means that it ignores. That means it ignores the negative values. It ignores the negative values. It ignores what? Negative values. Because from our previous cases, we had seen a situation where we have seen a situation where we have positive value or positive deviation as well as negative deviation. So when we have positive deviation, we pick it the way it is. When we have negative deviation, we also ignore the negative and treat it as positive. For example, I'm given the following data. I have 6, 7, 8, 9, 10. So 6, 7, 8, 9, 10 is the data I am having. So I will simply make a simple table to help me understand the concept of absolute deviation. So just write the data the way they are. Let me call them x's. So 6, 7, 8, 9, and 10. So I want us to get the deviation. Deviation we said is x minus x bar. So x bar is the mean. So we need to get the mean of this data. Somebody should work for us this x bar. What is the mean? You can do it. This is a very simple sum, or just take your calculator. You say 6 plus 7 plus 8 plus 9 plus 10. 6 plus 8, or 6 plus 7 plus 8 plus 10 is 40. Then we divide by 5. We get 8. So the mean of that data is what? Is 8. So once we have the mean as 8, we can now fill the column of deviation. So deviation we said is x minus x bar, which is the mean. So the mean in this case is 8, meaning that every data there, we are going to subtract 8. So x minus 8. So let's continue. 6 minus 8, that is 2. 7 minus 8, that is minus 1. Sorry. 8 minus 8, that is 0. 9 minus 8, that is positive 1. Then 10 minus 8, that is positive 2. So that is what we are calling deviation. What about now mean absolute deviation? Now let's first of all get the absolute deviation. Absolute deviation now is x into x minus x bar. That is the absolute deviation. X minus x bar. That is the absolute what? Deviation. So with the absolute deviation, we said we only take the positive values. We only take the positive values while we ignore the negative values. We only take the positive values and ignore the negative values. So like in this case, this negative 2 will just be treated as 2. This negative 1 will just be treated as 1. Then this 0 is just 0. The positive ones will always remain positive the way they are. The purpose of absolute deviation is to give, or is to remove, the negative signs from the deviations so that it doesn't affect our other statistical measures we are going to do in the subsequent case. So once we know the absolute deviation, we are supposed to now ask ourselves, how can we get the mean of the absolute deviations? Mean absolute deviation. Mean absolute deviations. Mean absolute deviations. So this is always abbreviated as MAD. Again, some students are calling it MAD. Oh, teacher, you are teaching us mad things. Oh, no, it is not mad. Yes, mean absolute deviation. So what is it? Mean absolute deviation is simply the mean of the absolute deviations. The way the name states, it is the mean of the absolute deviations. Yeah, we have already checked on what absolute deviation is. We know that in absolute deviation, we are just ignoring the negative signs from the deviation. So mean of the absolute deviation simply means we are going to add all the deviations or the absolute deviations, then we find the mean. So what is the formula? MAD, which is the mean absolute deviation, mean absolute deviation is the sum of the deviations. Sum of the deviations, or not some, the sum of the absolute deviations, sorry. The sum of the absolute deviations we divide by what? By n. So in our previous case, we can add all the absolute deviations. So sum of all these absolute deviations, like 2 plus 1 is 3, plus 0 is 3, plus 1 is 4, then plus 2 is 6. So the sum of the absolute deviations is equals to what? Is equals to 6. Is equals to 6. Now let's work this one out. So our MAD in this case, our MAD in that case will be the sum of the absolute deviations, will be the sum of the absolute deviations we divide by the total number of observations. So the sum of the absolute deviations, we have calculated it here. The answer here is what? 6. Then we are going to divide by the total number of observations. How many observations are here? 1, 2, 3, 4, 5. So divide by what? Divide by 5. Divide by what? By 5. So 6 divided by 5. What are we going to have? 6 divided by 5. 5 goes into 6, 1 point, remains 1. So 1, 10, 5 goes what? 2 times. So 6 divided by 5 is 1.2. That is 1.2. And that is now what is called the absolute what? The absolute deviations. So the third measure of deviation, the third measure of deviation is called the variance. It's called the variance. So let me just clear the board. It's called the variance. It's called the variance. It's called the variance. It's called the variance. So variance, variance, variance. Variance in this case refers to what is called the mean square deviation. So it is the mean of the squared deviations. The mean of the squared deviations. The mean of the squared deviations. Meaning, for us to get the variance, we need to square the deviations. After squaring the deviations, we find the what? The mean. So the same way we were calculating the mean absolute deviations, what we were doing is we were calculating the deviations. We add all the deviations. Then after adding all the deviations, we divide by the total number of observations. Now, when we come to variance, we are also going to get all the deviations. So instead of finding the absolute, the same way we were dealing with the MAD, we are now going to square those deviations. So in a quick recap, let me just say we were having 6, 7, 8, we were having 6, 7, 8, 9, as well as 10. Then we said deviation is x minus x bar, and our x bar in that case was 8. So in this case we were having what? We were having minus 2, 1, 0, 1, and 2. Then instead of now finding the absolutes, we square them. We square them. So when we are squaring, a negative number squared becomes positive. So this is 4, this is 4, this is 4, this is what? 1, this is 0, this is 1, as well as this is 4. So the sum of the squared deviations, will be 5 plus 5, which is 10. So somebody asked me to find the variance for this data. It's very simple. You say the sum of the squared deviations divided by what? By n. The sum of the squared deviations divided by n. And the squared deviation in this case is 10, n is 5. So the variance in that case becomes what? Becomes 2. So that is for ungrouped data. So we are taking a very short break. Then we come back to variance, and we will be now looking at how do we calculate the variance of ungrouped data. How to calculate the variance of ungrouped data. So let's take a very short break, then come back shortly with the topic. Okay, hope you've taken that short break. Welcome back to the topic on statistical measures. We were explaining the concept of variance, and as I explained before, I said that variance of ungrouped data is obtained by finding the sum of the deviation squared, or the sum of the squared deviations. Then we divide by the total number of what? Observations. Actually, variance is just the mean squared deviation. So don't think that if somebody asks you to calculate the variance, you're being asked to calculate a very big thing. No, variance is simply what? Is simply the mean of the square deviation. So you get the deviation the way you've been getting deviations, square the deviations, so you find the mean of these squared deviations. In other words, after squaring the deviations, you find the mean. That is simply what is called the variance. So the variance of ungrouped data, finding the variance of ungrouped data is very, very easy, because you can simply just take the deviations, find the squares, divide by the total number of observations, you get the variance. Now let's look into a case of ungrouped data. How do we now find the variance of ungrouped what? Data. Good. Variance of ungrouped data. 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 So I'm going to use an example. So let me just write variance of ungrouped ungrouped data. Variance of ungrouped data. Variance of ungrouped data. So variance of ungrouped data is always obtained. Variance is always abbreviated as S squared. Variance is always obtained by saying sum of fx squared divided by sum of fx squared divided by sum of x. Then we subtract sum of fx divided by sum of f, then everything here squared. Yeah, we are saying that variance in this case is the mean square deviation. So if you can see the second part is just the mean, but we are now squaring. So it is how far a data is from the mean. So let's use an illustration. So we are provided with our data here. We are given the class, then we are given the frequency. So the classes are 40 to 49, we have 50 to 59, we have 60 to 69, we have 70 to 79, we have 80 to 89, we have 90 to 100. And let me just say 90 to 100. That's the data we have been provided with. Okay, so that is the data we are having. So we are going to use this data to calculate the variance. So frequencies are given as 3, 5, 6, 9, 8, as well as 7. So that is the frequencies we are having for that particular data. So we need now to introduce some columns that will help us calculate the variance. Remember, we have said for us to calculate the variance, we need to get the sum of fx squared. The sum of fx squared. So we need f and we also need x. I believe now finding x is not a problem. X, we said, is the midpoint. So like in this case, 40 to 49, we say 40 plus 49, the answer we get, we divide by 2. That gives us 44.5. 50 to 59 is 54.5. 60 to 69 is 64.5. 70 to 79 is 74.5. 80 to 89 is 84.5. Then 90 to 1, this one should be 99. Let me just change that. 90 to 99 should be 94.5. So that is what we are having as x. So remember, we need x squared because we need fx squared. So we need x squared so that once we have the x squared, we can have fx and also introduce fx squared. Good. So that is what we are now going to work on in order for us to get the variance. So let's work out these columns. I hope you are having your calculator with you. So let me fill the column of x squared. X squared means that I'm squaring all the x's. I'm squaring all the x's. So 44.5, when I square, I get 1980.25. 1980.25. 54.5 squared, that is 2970. 2970.25. 2970.25. 64.5 squared. 64.5 squared, that is 4160.5. 0.25. Then 74.5 squared. 74.5 squared, that is 5550.25. Then 84.5 squared, that is 7140.25. Then the last one is 94.75. no, 94.5 squared. That is 8930.25. So we are done with the column. We are done with the column of what? The column of x squared. Now let's go to the column of fx. Remember, fx means f multiplied by what? By x. F multiplied by x. So this is f, this is x. So the two columns multiplying f by x. So like 3 times 44.5. 3 times 44.5, what do we have? 133.5. Here is 5 times 54.5. 5 times 54.5. 5 times 54.5. This is 272.5. Here is 6 times 64.5. This is 387. 387. 9 times 74.5. 9 times 74.5. 9 times 74.5. That is 670.5. 670.5. 8 times 84.5. 8 times 84.5. We get 676. Then 7 times 94.5. What do we get? 661.5. So that is the column of fx. That is the column of what? Fx. You simply take x, you multiply by the f. Now to the last column, fx squared. This is where most of the students always go wrong. Fx squared does not mean you square the fx. Remember, in this case, it is only x which is squared. That is what you need to know in this particular formula. That this x, it is only x which is squared, not fx. So fx squared is not equals to fx, then you square. It is not equal. So this one we say not equals to. So don't make an assumption, because I've seen several cases where a learner, after calculating the fx, so he brings that one into this case and say the total of this one you square. It is not that way. So work them independently. It is only x that is squared. And that's why we are introducing x in this particular formula. So we are introducing this x because it is the only one that we require in that scenario. So fx squared means that I'm going to take a column of f, I multiply by the column of x squared. So those two columns, that's what we get here, not squaring the fx. So continue. 3 times 1980.25. 3 times 1980.25. 1980.25. That one gives us what? 5940. 5940.75. 5 times 2970.25. That is 148.51.25. 6 times 4160.25. That gives us 24,961.5. Then 9 times 5550.25. What do we get? We get 49,952.25. Then now 8 times 7140.25. 8 times 7140.25. What do we get? We get 51 or 57,122. Then the last one, 7 times 8930. 7 times 8930.25. What do we get in such case? That is 62,551.75. So we have introduced all the columns that are required. All the columns are required for us to calculate the variance of ungroup data. We have f, we have x squared, we have fx squared, we have fx, we have f. So the only thing that is now remaining for us is to find the sum of each and every part. So let's try and find the sum of each and every part that is required here. We are not going to find the sum of x. We are not going to find the sum of x squared because these are not needed in the formula. We are only required to get the sum of f, the sum of fx, and the sum of fx squared. So let's do the addition. Sum of f. 3 plus 5 plus 6 plus 9 plus 8 plus 7. That gives us 38. So the total in this case is 38. Let me go to fx. I don't need the total of these two columns. These two columns, I don't need the total. So I'm going to fx. fx is 133.5 plus 272.5 plus 387 plus 670.5 plus 676 plus 661.5. What do we get? 2801. Now let me go to the column of fx squared, a column of fx squared. So 5940.75, 5940.75 plus 148.51.25 plus 24,961, 24,961, 24,961.5, 24,961.5, then plus 49,952.25, we add to 57,122, we add to 62,551.75. Good. What do we have? 215,395 or 379.5. So we have the totals that we will now be using. So we have the totals that we will now be using if we'll be using to calculate the what? The variance. You know, some students always give up when it comes to filling the table. Actually, the key thing in this, or the key part that you're supposed to know in this topic, is just filling the table, because at the end of the day, what we are doing is just substituting from the formula. So you may have the formula, but the formula will not be very much helpful if you are not able to come up with this table. So come up with this table, ensure that you are accurate in each and every section. So let's calculate the variance. Let's calculate the variance. Let's calculate the variance. So we said that variance, that is var, the variance, which is a variance, the one which is always abbreviated as x squared, is the summation of fx squared divided by summation of f. Then the answer we get here, we subtract. The answer we get there, we subtract the summation of fx. We subtract the summation of fx divided by what? Summation of f. But this second part, the answer we are getting in the second part, we square. So let's continue. Summation of fx. Summation of fx. Summation of fx we have said is what? No, the summation of fx squared. We have said it is 21 or 215, 379, 379.5. 379.5. That is the sum of fx squared divided by the sum of f. The sum of f we had said is what? The sum of f here is 38. So we divide this one by 38. Subtract the sum of fx. The sum of fx is 2809. 2809. This one is divided by sum of f, which is still 38. But now we say the answer we get this side, we do what? The answer we get that side, we square. The answer we get this side, we square the answer. We get that side, we square. So let's work this one out. 215,379.5 divided by 38. Divide by 38. Divide by 38. So the first part becomes 5667.88. That is to 2 decimal places. Minus. Let's work the second part. 2801. 2801 divided by 38. 2801 divided by 38. That is 73.71. Then we square that. When we square that, what do we get? We get 5433. 5433.24 to 2 decimal places. 0.24 to 2 decimal places. So our variance therefore will be 5667.88 minus 5433.24. What do we get as the variance? The variance for that data is 234.64. 234.64. So that is the variance of that particular data. So I hope you have seen how we are getting the variance of this particular data. The variance of this particular data. So after variance, there is a next closed measure. There is a very next closed measure of variance. This closed measure is called standard deviation. Actually, we always calculate the standard deviation. We calculate the standard deviation from the variance. So how do we get it? Let me just write it here. Standard deviation. Actually, there is no peculiar calculation of a standard deviation. The calculations of a standard deviation, depends. The calculation of a standard deviation depend entirely on the variance. So depends entirely on the variance. So standard deviation in this case is equals to the square root of variance, meaning once you have calculated the variance, you can now simply calculate the standard deviation. So once you have calculated the variance, you can calculate the standard what? Deviation. So if somebody asks you to calculate the standard deviation, what they are asking you in simple term is that you are supposed to calculate the variance, because it is the variance that gives you the standard deviation. For example, in our data above, our variance was 234.64. So if I want the standard deviation, I will just say 234.64 square root. 234.64 square root. So answer, that one gives me 15 point what? 15.32. 15.32 to 2 decimal places. 15.32 to 2 decimal places. And that is now what is called variance of standard deviation. So in summary, if somebody asks you to calculate, the standard deviation, what you need to do there is to calculate the variance. So the only thing you need there is the variance. Are we together? Yeah, so know how to calculate the variance using the direct method. You can calculate the variance using the direct method, which is this one. Get sum of fx squared divided by sum of f. We subtract the sum of fx divided by the sum of f, but you square. Once you have calculated this one, definitely you simply find the square root, you'll get the what? The standard deviation. Good. Apart from this formula, we also have another formula that we can use to find the variance. That is the deviation formula. You remember in the previous case when we were dealing with the ungrouped data, we say that what we do in such a situation, we use the deviation. So even in the case of a group data, we can still use the method of deviation. We can still use the method of deviation to calculate the variance. So I want us to now go into that again and look at how can we use the method of deviation to calculate the variance. So the formula will still remain the same. The formula will still remain the same, except this x in the formula is what is replaced by d. The x is replaced by d. So this x here, the x in this formula, we are going to replace by deviation. We are going to replace by deviation. So it will be d, it will be d. So it is a sum of d squared, meaning I will not need a column of x squared. I will also not need a column of fx squared. Instead, these two columns, the column of x I will replace by what? D. Then the column of fx squared I will replace by fd squared. So this one becomes now d. This one now becomes d. Then this one also becomes d squared. So let's just work out from this. Let's just work out from this. So let me just make some little amendment here. I want to use the same and see if we are going to get the same answer. So these are the only things that we're going to change here very fast. We are going to change something here very fast. We are going to change something here very, very fast. So this one here and this one here are the only things that are going to change in our formula. So D, I said that when we want to use the concept of deviation, we say that d is equals to x minus x bar, or x minus a. And the assumed mean in this case is the midpoint of the middle class with the highest frequency. So we will be using this one as an assumed mean. So our a in this case is 74.5. Our a in that case is 74.5. So every data here we subtract 74.5. So let's go. 44.5 minus 74.5. What do we get? Minus 30. Minus 30. 54.5 minus 74 minus 20. 64.5 minus 74.5 minus 10. This one is now 0. That one is now 0. And this one in this case is 10. And that one is what? 20. So that we now get f times d squared. So I will square the d's, then multiply by f. Or if to avoid much doubt, let me just write here d squared. Then I have fd squared. Good. So d squared minus 30 squared is 100, 900, 400, 100, 0, 120. Then we can now have fd squared, f times d squared. This is now 2700. 5 times this one, 2000. 6 times 100, 600. 9 times 0, 0. 8 times 100 is 800. Then 7 times 20. No, this is not 20. This is 400. Yeah. So 7 times 400. 7 times 400 is 2800. Yeah, 20 squared is 400. When we multiply by this one, we get 2800. So we can also get the sum of now the fd squared. Sum of fd squared. So 2700 plus 2000 plus 600 plus 800 plus 2800 plus 2800. We get 8900. So we said we can still get the variance using the summation of FD squared minus summation of FD then square. So let me just work it here. So variance in this case will be the sum of FD squared, which in that case is 8900, all over the sum of F, which is 38. The answer we get here, we subtract to sum of FD, sum of FD, sum of FD. Oh, we didn't introduce FD. Okay, we didn't introduce FD. We didn't introduce FD. Oh, we are supposed to replace this one here. The FD, FX. We don't need FX, we need FD. So this one needs to be replaced. So FD, this is minus 90. This is minus 100. This is minus 60. This is 0. This is 80. And this is 140. Good. That is 140. So we can get the sum minus 90 plus minus 100 minus 100 minus 60 minus plus 80 then plus 140. Good. So this one we said is minus 30. So minus 30 all over 38 then squared. So these two, when we subtract, we are supposed to get the variance. So somebody can work out that. Somebody can work out this one so that you can get the answer for this. Work out this, you get the answer. We see what you are getting after this short break. So we are going to take a short break as you work out this one. When we come back, we get the answer. Okay, so this is the variance. So I want you to go and work out this one. Work out the value of the variance from this particular information. I believe this one we can all get it. So go work it out. We come and check whatever you have gotten in our next class. So we take this opportunity to thank everybody who has been watching or following us throughout this particular lesson. So we meet in our next class, and the first thing I'll be asking in our next class is the solution to this particular problem. Thank you and have a wonderful day ahead.